All right, thank you. All right, hi everybody. My name is James, and we're going to be talking about some pretty cool stuff today. Before I actually get started, though, just a quick question. So by show of hands, how many of you guys have any experience in forensics? Oh, wow, a lot of people. Okay, that's awesome. So about a year ago, I took a forensics class, and when we got to the section on VSS, I remember just being amazed at how much awesome stuff you can pull out of those snapshots. Is so much information that people don't even realize is being recorded. And honestly, when I saw that, I thought to myself, man, your guys' job is just way too easy. So I decided to take a few weeks of my time to make your guys' jobs a little bit harder. No, I am kidding a little bit. You know, I do love you guys. I know a few forensics people, but snapshots are surprisingly easy to mess with, and we're going to see that in just a second. All right, so what are we actually going to be talking about today? First, we're going to cover the basics of what VSS actually is and what it's used for. We're going to cover a few reasons why you should care about it if you don't already. Then we're going to proceed on to what it actually looks like on the disk itself. This is where we start to get into some of the really cool technical details. After that, we're going to go to describe how we actually modify a snapshot, though. This is the really cool stuff. Then we'll go ahead and actually demo that, and we'll go ahead and modify a snapshot. And finally, we'll talk about a few different ways you can tell if a snapshot that you're looking at has actually been modified or not. So, first of all, what is VSS? According to Microsoft, VSS stands for Volume Shadow Copy Service. I'm not sure how that acronym works out. This is what they say. If you have an issue, take it up with them. So, the two areas that most users will encounter VSS is previous versions and system restore. Those two features make use of VSS to actually work. So previous versions, if you accidentally delete a file or modify it or something, you can pull an old version out of a snapshot. System restore, if a system update fails, if you install a bad driver, you can just roll back the whole system. It's pretty cool. So what VSS actually does is it keeps track of changes that are made to the files to enable this. So at a disk level, what's actually happening is before you actually write data onto a disk, the VSS service actually copies the old data before it's overwritten and stores it in the snapshot space. This is called copy on write. This appears in a lot of places, not just VSS. And so let's actually go ahead and take a look at what that looks like. Here we have our hard drive, and this blue space is the space that's reserved for snapshots. The space may or may not have anything in it. Right now, we don't know. Honestly, we don't care too much. So when we want to write some data to the hard drive, we figure out where we want to write it. In this case, the little highlighted block. Before we write it, we copy our data over into the snapshot space. Then we proceed with our write. We write our new data onto the hard drive where we decided to. And at this point, we have our new data safely on the disk, and our old data is safely in the snapshot. So this is what Windows is doing constantly in the background as you're using the OS, as you're writing to the disk. So how does Windows actually take this and go back to the snapshot, though? Let's go ahead and take a look at this. So we start with our disk, how we just finished in our last example. And what we do is we create an overlay of sorts from the snapshot. So that gray block ends up being placed in the overlay where it used to be, which is where the green block is. And when we apply this overlay on top of the current disk, we end up with a view of the disk when the snapshot itself was actually taken. All right, so back to more basics about VSS. It's enabled by default on every system since Vista. It creates snapshots automatically. Daily on Vista, that was using a lot of disk space, so they changed it to weekly on Windows 7 and later. The system will also take snapshots automatically when you install system updates, new drivers, that sort of thing, so it can roll back if needed. And it deletes old snapshots as necessary. It only uses a certain amount of disk space for those. So an interesting little side note is that this is not just used for system restore in previous versions. For example, MS SQL Server actually uses VSS to make backups while it's running. So the SQL Server will briefly put the database into a consistent state. It'll pause writes, and it tells the VSS service to take a snapshot. And as soon as the service is done taking a snapshot, the SQL Server goes back to writing to the database, doing all of its normal stuff. And then SQL Server can take its time writing out that snapshotted data to the hard drive. It can compress it, send it wherever, do whatever it wants. So this is actually one really interesting case. The two groups of people who know the most about VSS are forensics people and DBAs. I'm really not kidding. Like, if you go and talk to your DBA about VSS, they will go on and on for 20 or 30 minutes. I made that mistake one time. I'm not going to make it again. Another little interesting side note is actually that early ransomware authors didn't know about VSS just like most users. So it turns out with the early ransomware, you could actually just right-click on your encrypted file, select previous versions, and then restore an unencrypted copy of the file when you're, the ransomware authors obviously caught on to that pretty quickly, and they delete snapshots now. But for a little while, there you go. Why should you actually care about it? I mean, if you're not a forensics person or a DBA. Well, first of all, it's enabled by default, so it's pretty much going to be running on any Windows system you actually interact with. One of the most important things about this, though, is that secure deletion of files becomes really difficult, or much more difficult at least. Because when you intentionally write over a file to try to destroy its contents, the VSS service is actually going ahead and making a copy of the data you're trying to overwrite right before you overwrite it. So you go out of your way to destroy data, and Windows is going out of its way to preserve that data in a snapshot. And once data is in a snapshot, you cannot individually remove or modify files, until now at least. The best you can do is delete a snapshot and overwrite your disk space and hope that covers it. And because most users don't know about VSS and don't realize all the stuff that's in there, snapshots frequently contain evidence of crimes or simply private information, tax documents, any sort of other personal stuff. Let's go ahead and actually look at a few cases where VSS came into play. Our first case is New versus the state of Georgia. I'm sorry to start the first example off with a pedophile, but it is what it is. So this guy had a whole bunch of child porn on his system. He knew the cops were coming for him. He ended up deleting all of the child porn and wrote over all of his free disk space. Ordinarily, without VSS, this probably would have destroyed the data. In this case, the police take his computer. The first thing they do is look at the snapshots, and they pull out all the child porn he just tried to destroy. He obviously got convicted. The next case we have is USA versus Michael Thomas. This is a really interesting case. This was actually in the news a few years ago. So this guy, he deleted a whole bunch of his employer's data right before he quit his job. And so at this point, you're probably thinking, that the cops went to his workstation or his desktop and looked through his snapshots and found evidence of his guilt. That's not what happened in this case. He actually goes into court, and he employed what's referred to as a novel legal theory. He went into court and he freely admitted that he destroyed all of that data. He argued, though, that all of the data he deleted was safely stored in snapshots, so it didn't actually impact the availability or integrity of the data. As you would expect, this didn't work. He was convicted. If you ever get arrested, do not use that defense. It's not just used in criminal trials, though. The next case we have is actually an example of a civil case. HMS Holdings Corporation versus Arendt et al. This is sort of similar to the last case, but in this case, the former employees were accused of stealing confidential information rather than destroying it. So the defendants allowed for forensic examiners to look at their system. The forensic examiners look through the snapshots, of course. They don't find any of the files that the defendants are accused of stealing. They do, however, find evidence of file shredding tools, and they even find logs that indicate those tools were used to destroy the files they were accused of stealing. So even if the data itself isn't in the snapshot, you might still be out of luck. Okay, let's get on to the good technical stuff. What does it actually look like on the disk? First of all, Microsoft will not tell us. They have published absolutely no documentation about the on-disk format. They've published plenty of documentation for users, for admins, for developers. So if you want to know how to use it, great. If you want to know how it works, not so great. Fortunately, there's this dude named Joachim Metz, and he will tell us. He spent months of his own time researching the on-disk format, as well as researching some more cool technical details about it. And the really cool part about this is he didn't just keep this information to himself. He actually published detailed documentation online. So this is how we know how VSS works. It's basically because of him. Not only did he publish documentation, he also created an open source library called libvshadow. The link's at the bottom of the page. It's also on a later slide. And this open source library actually allows us to read from snapshots. It's a cross-platform library. Pretty cool. So basically, he spent months, so I could spend weeks, so you can spend hours to frame your next door neighbor. And I'm obviously just kidding. It only takes minutes, not hours. Okay, so that's great and all, but really, what does it look like on the disk? It's pretty much a bunch of linked lists and 16 kilobyte blocks. Someone at Microsoft just absolutely fell in love with 16 kilobyte blocks. If you don't know how big something is, it's probably 16 kilobytes. So the on-disk format isn't really all that complex. Unfortunately, though, we don't know everything about it. When we encounter something we don't fully understand, we kind of just wing it, and it generally works, and we kind of just go with it. As long as it's working, don't ask too many questions. All right, it consists of an NTFS header, a catalog, and stores. Each store holds a single snapshot. One snapshot, one store, one store, one snapshot. They're basically synonyms. The catalog contains information about the stores/snapshots, and the NTFS header simply tells us where to find the catalog. Let's go ahead and take a look at that on the disk. So here we have the NTFS header at the beginning of the drive. This is in a known fixed location. We have the catalog, and in this example, we have two snapshots, store 1 and store 2. The NTFS header tells us where to find the catalog. The catalog tells us where to find the snapshots. So the whole point of this thing is for us to actually modify snapshots. So once we've located the snapshots, we don't really care about the NTFS header or the catalog anymore. They hold some cool information, but we're not concerned about them. We're really just concerned about the snapshots themselves. The next obvious question is, what is in a store? It's a whole bunch of stuff. You've got a header, you've got data block list, block range list. There's a ton of stuff. We don't need to be concerned about most of it, though. We really only need to worry about the data block list and the data blocks themselves. The data block list, it's a linked list structure, and it keeps track of changes that are made to the snapshot. The data blocks are just the data themselves. It's just 16 kilobytes of raw data that was saved in the snapshot. The data block list elements, each element of that data block list has a bunch of block descriptors. The block descriptors are what actually describe the changes. So let's go ahead and take a look at this so it makes a bit more sense. So in this case, we have an example snapshot with 3 data block list elements. Each one simply points to the next in the list, and each one holds a whole bunch of block descriptors. It's 508, but that's not really important. And each block descriptor describes a single 16 kilobyte change. All right, so one more time, let's go over how Windows saves data to a snapshot, but in a little bit more detail this time. We want to write some data to our hard drive. First, we copy the old data to the snapshot. We write our new data. Now, this old data that we wrote to the snapshot, it's referred to as a data block, just 16 kilobytes of raw data. Now what we do, we create a new block descriptor. And this new block descriptor simply tells us where the old data used to be. It just tells us that where the gray block is now, it used to be located where the green block is. So when we create our snapshot overlay, that little arrow showing where the gray block used to be, a single block descriptor describes that arrow. It tells us how to draw the arrow, basically. And of course, it gets more complicated. There are a whole bunch of different types of block descriptors. Fortunately, they all serve the same basic purpose, though. I would like to point out, though, that the unknown type of block descriptor in that list, this is an example where we don't fully understand everything. We kind of just do our best, and it usually works. Okay, so let's get on to the really good stuff. We've seen how Windows reads and writes to snapshots. Now let's see how we actually tamper with an old snapshot. So it's actually pretty simple. In this case, we start with a good base. So we start with lib vshadow, slap on a few thousand extra lines of code, spend hours fixing really stupid bugs. Next thing you know, you have write support. It's a little more complex than that, but that's the gist of it. Okay, so what we're really doing, though, is we're basically doing what Windows does, but we're doing it backwards. When we want to write data to a snapshot, instead of writing it to the disk and copying the old data, we just write our data directly into the snapshot itself. Then we create a block descriptor that says that the data in the snapshot used to be somewhere else. We're going to go ahead and take a look at this. So this is how we tamper with the snapshot. We have our disk as it currently exists at the top. We have our snapshot overlay. When you apply the overlay, you get the disk when the snapshot was taken. So we work backwards, and we want our snapshot to look like this. We want to add those 3 evil red blocks into our snapshot. In order to do this, we work backwards. We have to have those 3 red blocks appear in our snapshot overlay at the correct location. In order to do that, those 3 red blocks need to be in the snapshot space, and we create block descriptors to draw those arrows so we know to put those 3 red blocks into the overlay in the correct location. And just like before, we apply our overlay, and now our snapshot looks how we want, not how it actually was. So, as I mentioned, it's not quite as simple as just adding on code and spending hours doing stupid stuff. There were a lot of issues that I came across. I'm not going to spend 6 hours covering all of this stuff. You guys don't have the time. I don't care to. All the explanations and examples, though, are on GitHub. The link will be on later on the slides. OK, so let's cover the actual demo. Let's see it. So in this case, I'm going to be demonstrating the Linux version of, Jesus. Demo failure with the video. I did not sacrifice to the demo gods. Let's take a look at this. I'm going to be demonstrating the Linux version, actually. The Windows version's in progress. We just have an issue with drivers and writing to raw disks. So let's go ahead and take a look. So this is our Windows VM, and we have drive Y. This is the disk we're going to be messing with. So the guy who uses this machine, he loves sysinternals. He's always talking about nonstop. It's really annoying. I love sysinternals too, but seriously, shut up about it. We're going to delete sysinternals from his disk because I know he's just going to go back into a snapshot to restore an old version. So let's go ahead and take a look at our previous versions. This is our snapshot data. And if we go ahead and look at the oldest snapshot, we can open that up. We'll see sysinternals is still there. Now, you could just right-click on the directory and actually select Restore, and it would actually push it back to the current volume. So we can see in this case, all the sysinternals data is there. So we're going to go ahead and shut down the VM, and we're actually going to tamper with it. The snapshot, not the VM. So in just 1 second, we are going to be using our modified version of vShadow mount. There's the -W option was added that enables write support. In this case, the snapshots from that disk are going to appear in MNT/VSS work. If we go ahead and look in there, we see VSS1, VSS2. Those are our 2 snapshots. So we can actually mount these files as if they were disks themselves, and it's basically a view of the snapshot. So the snapshot we want to modify is VSS1. We're just going to go ahead and mount that using normal tools. It's going to be read-write. And let's go ahead and take a look at it. So if we see sysinternals is there, we can go ahead and take a look inside the directory. All the files are still here. This is just what we saw in Windows. But we're going to start modifying it. We're going to get rid of these files. And I, for one, love boating. This guy needs to love boating, too. Let's copy a boat picture. After we do that, we can see the boat pictures there. We go ahead and unmount our snapshot. We unmount our VSS working directory from vShadow mount. And then let's go ahead and start up the VM again. Let's go ahead and skip through a minute or 2 of system starting up. And we're going to go ahead and open up that snapshot and take a look at what's inside. So we just go ahead and right-click, Properties, Previous Versions, and we're going to open up the same snapshot we just looked at. We open it up. We take a look inside the sysinternals directory. Those files are gone. Our boat picture is now there. He does need to buy a boat. Obviously, instead of a boat picture, we could have put, other funny cat pictures. I just chose the boat picture.
What did it
I'm going to talk about that in a second. That's a really good point. So, what you just mentioned, how can we tell if a snapshot's been modified? So in this example, I just used normal tools to copy a file in there. So when I copied that file in there, if you would look closely, you would have noticed that the snapshot was from a few days ago. The file I just copied has timestamps from a few minutes ago when I just copied the file. This is one way that you can tell. This is one of the easy ways. Look for anomalous timestamps. Files that have timestamps that don't belong, they should raise a red flag. Other things that you can look for event logs, you can look for timestamps in other files, any known activity that the user performed. If you happen to know for sure that the computer was turned off at a certain time and there's a file that has a timestamp from that time, that might be a red flag for you. So you look through your normal stuff and you just look for stuff that's out of place. There are also plenty of hard ways to find out though. What it really comes down to is Windows does some funky things when it's writing to snapshots, libvshadow does some funky things when it's reading from snapshots, and my modifications to libvshadow does some funky things when it's writing to snapshots, and those funky things don't always line up. So this is definitely a lot harder. If you are curious, you can look through the code, you can look through documentation on it, and there will definitely be more details. So links, the good stuff. So on the top we have, this is me on GitHub. So the code and the slideshow are going to be up there. It's not up there right this second, it will be later today. And then below that, we have the regular unmodified libvshadow. This is just straight from Joachim Metz. His documentation's also in that repo. If you want to find out more about VSS on the disk, look through the source code and his documentation. I'll go ahead and leave this up for a second.
So what if you touch a file with a previous timestamp prior to uploading?
So it's going to depend on the exact tools you use. If you just use regular tools, it's going to update the timestamps.
I'm talking about touch specifically. You should be able to.
Oh, you're talking about modifying the timestamps?
Right, or UTMP or whatever.
Yes. If you modify the timestamps so they fit in, it's not necessarily going to be obvious.
And there won't be any way to really catch it.
Not an easy way. You can look for the harder ways.
Just want to make sure my path is clear.
Yeah.
It'll depend on which timestamps that.
Yes. Yeah, NTFS has like 12 timestamps. All right, just a really quick thanks. Joachim Metz for doing all the hard work and documenting it so I can just swoop in, talk about it, take the credit. Chad Tilbury, he's the guy who actually taught the forensics class that I mentioned earlier. Patrick Thomas, my BSides mentor. If you understood the content of this presentation, it's his fault. All right, are there any questions? And also source code, email address. Behind you.
So, given limited understanding of the VSS format beyond what you've said, my understanding is it's possible to essentially reconstruct timelines from it, and it's a fairly standard forensic process using essentially the set of entries to identify a pattern of changes. Have you looked at the problem of creating anomalous changes such that it's very obvious exactly what you changed because essentially it blips in existence and then modifies out and it just doesn't fit the time flow? And have you thought about how to fix that problem?
Yeah, that's definitely an issue. I think you might be talking about two different things there. One is basically if you modify a single snapshot, what about the snapshots on either side of it? Yes, that is something you'd have to handle manually. The code doesn't really do anything about that at the moment. So you modify a single snapshot, it's not going to be on either side.
We can delete one side.
Yeah.
Solve that issue.
Yeah, you can delete and add freely.
Yeah, what other data, metadata is preserved when you take a snapshot? Does it include extended attribute set? Does it include alternate data streams?
Okay, so that's a good question. So all the data that gets snapshotted, it actually gets snapshotted on the block level. So whenever you edit a file, whatever actual changes occur to the disk on the block level get backed up. So it doesn't, VSS itself doesn't actually care about file systems or anything like that. Anything that gets changed on the disk will get saved in the snapshot, attributes, alternate data streams, all of that.
And that's all the time we have. Thank you very much.
All right.
To our speaker. Give him a big hand.
Guys.